Hi, welcome back. In this video, we're going to talk about function operations. Now, in our past unit, we were talking about functions and intro to functions, how to evaluate, find a domain and range, things like that. Now we're going to talk about the same things, but with a combination of functions. As you can see here, we have addition, subtraction, multiplication, and division. An operation is really just these things that we're doing, right? The product, the sum, the difference, the division of these things. And we're going to do that with two different functions. So this notation, right, we're used to seeing f of x on its own. And this notation is talking about what happens if you have two functions and add them together. So another way to look at this is to say f of x plus g of x. Right? We're adding two functions now, and we're going to get a different result. We can also separate this into f of x minus g of x. And we can do the same thing for every operation. F of x times g of x and f of x divided by g of x. This is the beginning of our compositions unit, right? Composition of functions, where we're going to create a new function after adding them, subtracting, multiplying, and dividing. So let's get to it. Let's do a few examples. As you can see here, we have two functions. We have f of x and g of x. And in this scenario, I want to know what happens when I multiply them together. What do we get when we multiply f of x times g of x? Right? This is the notation that we're using. I'm going to multiply these two functions by using the FOIL method. We can also multiply these using the box method, which we can talk about here in a minute. Depending on what method you prefer, right? I'm going to do FOIL method first, and then I'm going to do box method, maybe something that you remember from Algebra 1, Algebra 2. When I multiply, I'm going to take this first term and multiply it times the first term. Negative 3x times x squared is negative 3x cubed. Sorry about that. And when I multiply the negative 3x times the second term, I'm going to have negative 3x times 2x gives me negative 6x squared. Negative 3x times 4 is negative 12x. And I repeat this process for the next one. Now I have positive 2 and distribute it into all the other terms. 2 times x squared is positive 2x squared. 2 times 2x is positive 4x. And 2 times 4 is positive 8. If I were to do box method, I would get the same thing, right? I would put my negative 3x, positive 2, x squared, positive 2x, positive 4. And when you multiply everything, right, negative 3x times x squared is negative 3x cubed. You multiply these two terms, negative 3x times 2x, you get negative 6x squared. Negative 3x times 4 is negative 12x. 2 times x squared is 2x squared. 2 times 2 is 4x, and 2 times 4 is positive 8. I get the same values that I got here. They're all in the same thing, right? All I would have to do now is combine like terms. Now there's only one term with a cubic value, so I'm going to leave it as negative 3x cubed. I notice that there's two terms with an x squared, this one and this one. When I add negative 6x squared and positive 2x squared, I get negative 4x squared. And then when I combine the negative 12x and the positive 4x, I get negative 8x. And then the 8 is by itself as a constant. So this is my new function. This is the result of saying f times g of x. My new function is a cubic function. I started with x squared with a linear, and when I multiplied them, right, and I can show you what that looks like here in a minute. When I multiply the two, I get a new equation. Now I want to find out what is the value at 1 for this new equation. So I take my equation, and I want to know the value at 1. What is the value of 1? So I take every x value, plug in 1, and I do PEMDAS. PE, that's supposed to be a P. MDAS. Inside the parentheses, there's just one number. The next part is the exponent. So 1 to the third power is 1 times 1 times 1. 1 squared is 1 times 1. And then it's multiplication and division. So multiply them times 1, negative 3, negative 4, negative 8, plus 8. I'm just multiplying everything times 1. And then addition and subtraction. This gives me negative 7. This gives me negative 15. And this gives me negative 7. The new function that we created is now evaluated at 1, and the value is negative 7 as my output. How can I check my work to see if I got this correct? Well, this is the same thing as saying, what's the value of f at 1 times what's the value of g at 1? If I plug in 1 to the original equations, what do we get? So when I plug in 1 in here, now I got 1 squared plus 2 times 1 plus 4. This is me just checking my work. When I simplify it, I got 1 plus 2 is 3 plus 4 is 7. If I plug in 1 in here, now I got negative 3 plus 2 is negative 1. What do you get when you multiply the f function at 1 times the g function at 1? Well, 7 times negative 1 is still negative 7. So I know I did my math correctly. So let's break down what we just did. We took two functions and we multiplied them together to get a brand new result. If I break this down a little bit further, here's what's happening. I have some sort of a quadratic. This is my f function. Some sort of x squared, right? And then I have my g function with a negative slope, something like this. This is my g function. And what I'm doing is I'm going to take each point at 0, I'm going to multiply them together. And I'm going to plot it. I'm going to take the next point, these two values, and at that point, I'm going to plot it. And then when you multiply all of the points, right, in these functions, this is basically just a bunch of points. When I multiply all the respective points together, I'm going to get a brand new graph. And in this case, it looks something like this, because it's a cubic function. And we'll talk more about that later. This cubic function is the result of multiplying the two functions together. This is really what's happening. I take every point on f, every point on g, and as I multiply them together, we're going to get a brand new points. And when I connect them, I get a brand new graph, a brand new equation. And now I want to find out what's the value of the function when it's 1. So when x equals 1, I got negative 7. All right. Now, moving forward, I'm going to do the same thing now with addition, subtraction, multiplying, or dividing. And then if you fast forward towards the end, I will also be doing an example with a graph. Right? So let's do all the order of operations. Here we're going to do the addition of the two functions, f of x plus g of x. So let's add them. This function is 3x plus 3. And I'm going to add the other function, negative 4x plus 1. This is just f. This is just g. When I add them, 3x plus negative 4 is negative 1x, and 3 plus 1 is positive 4. This is my new function. What is the value of this new function? Right? This is just f plus g. What is the value at 10? So let's plug it in. If I plug 10 in there, sorry, this is supposed to be a 4. Negative x plus 4. If I plug in 10, I get negative 6. And I can check my work, right? I can plug 10 in here. 3 times 10 is 30, plus 3 is 33. Negative 4 times 10 is negative 40, plus 1 is negative 39. When I add them together, I also get negative 6. this is a great way to check your work. Plug 10 into the original equations and then do the math of addition, of subtraction, or whatever we're doing. All right, let's talk about subtraction. Very similar here. For subtraction, I'm going to do g minus f. So I'm going to take the g function and subtract the f function. So g is just x cubed plus 2x. And I need to subtract all of that. So I'm going to put it in a parentheses. Because that minus, I know it's going to affect this part and this part. So I'm going to distribute here when I subtract. All right, I got x cubed plus 2x minus 4x plus 3. Right? Negative times a negative is a positive. And now I can combine like terms, which are these numbers. I get x cubed minus 2x plus 3. This is my new function of g minus f of x. Now my new function, I want to know what is the value at 3. So let's plug it in. Plug it in here. Plug 3 for every x value. And of course, do PEMDAS. 3 times 3 times 3 is 27 minus 6 plus 3. 27 minus 6 is 21 plus 3. Gives me 24. And of course, I can plug 3 in here, plug 3 in here, and then do subtraction. All right, our last example is division. I'm going to divide g divided by f. So I'm going to take the g function. Right, this is just g of x divided by f of x. So take g, 4x plus 2, and divide it by the other one, 2x minus 4. What's the result? Well, here I can't just cancel the x's and cancel the numbers, because technically this is an entire function put together. And since I'm dividing, the only time I can really cancel is if I'm doing multiplication. But I'm not. I'm doing addition on top and subtraction on the bottom. But I do notice that the top is divisible by 2. So what's divided by 2? What do we get when we get 4x plus 2 divided by 2 divided by 2? 4x divided by 2 is 2x, and 2 divided by 2 is positive 1. In the bottom, I can do the same thing. 2x minus 4, they both have a 2 in common. So divided by 2. 2 divided by 2 is just x. And then 4 divided by 2 is negative 2. It's a minus right here. Now that I have separated the 2 from the top and from the bottom, I can start to cancel things. This is my new function. g divided by f is actually 2x plus 1 divided by x minus 2. I only want to simplify if they have common factors on top and in the bottom. So let's evaluate it. What is the value at 3? So I take my new function, 2x plus 1 divided by x minus 2, and plug in 3 for every x value. 2 times 3 is 6. 6 plus 1 is 7. 3 minus 2 is 1. 7 divided by 1 is 7. So all of these examples have been operations with the equation, right? Given the equations. Let's do something similar with the graph. And here's our last example for the day. For the graph, now I'm going to plug it into the graph versus into the equation. Okay? So what does this say? This tells me what is the value at 0 when I add the two together. I have some sort of cubic function and a quadratic. So I want to find the value of f at 0. I want to find the value of g at 0, and then I'm going to combine them. I'm going to add them together. So when I go to the x-axis, x is 0 right here. The output is 0. What about g? When I go to 0 as the input, g is down here at negative 2. This point on the graph is the output at that value. I go to the input of 0, which is the x-axis, and I find where is it on the graph. and then I can add the numbers. -2. Same thing for subtraction. F of -2 minus g of -2. Can I find the value of f at -2? Go to -2. What's the value of f? F is down here at -1. What is the value of g at -2? Well, g is up here at +2. The input is the x value, is the x-axis. The output is the location on the graph. So, -1 minus 2, -3. Let's do the multiplication and division. So, I'm going to take the value of f at -4 and multiply it by the value of g at -4 as well. So, when f is -4, the output is down here, -2. G at -4 happens to have the same value. The output is also for this red graph and for the blue graph. It's both at -2. So I'm just going to multiply -2 times -2, which gives me +4. The goal here is we're not plugging it in for all the x values like we did earlier, right? Earlier, we were plugging them in to all these x values and then doing PEMDAS. Here, we're plugging it into the graph. And the output, we're going to do adding, subtracting, multiplying, and then here division. So what's g of -2 divided by f of -2? Let's divide this. Well, at -2, g is +2. Right? G is located here. When the input is -2, g is +2. What about f of x? When this is the input, f is down here at the bottom. F of x is -2. Sorry, -1. And then -2 divided by -1 is -2. So that's how we do it. The idea here is that we're taking two different functions and we're combining them to get a brand new function through addition, subtraction, multiplication, or division. And then we're evaluating at every location. If I had another graph with all the points being added or subtracted or multiplied or divided, I would get a whole new picture here that would look very different. And for that picture, we'll find the domain and range and all that stuff. But those are in the next few videos. For now, please let me know if you have any questions. And as always, we'll calculate.